This is topic 6 in Unit 1, frequency distributions. A frequency distribution is probably what you would think of when you hear tally chart. It basically shows how dataset is partitioned over a certain number of equal length categories, which we're going to be calling classes. Classes must not have any jumps or breaks. Typically, when we make a graph for data, we will usually start with a histogram. Ideally, a histogram will be made using statistical software. However, it's very important to understand how to actually make a histogram because that is very crucial to understanding how to interpret this type of graph. In order to make a histogram, you're always going to start with a frequency distribution. One note of this is that you can use a frequency distribution on its own. It does not need to be something that is always turned into a histogram. So there is a lot of lingo that comes along with a frequency distribution. It's more important to understand these terms when you hear them as it is to than it is to actually know the definitions for them. So we have 5 definitions here. Lower and upper class limits describe the smallest and largest numbers that belong to different classes. So remember, the classes are the breakdown of the categories from the data set. Class boundaries are the numbers that occur between each class, so it's going to be the exact middle between the end of one and the start of the next. A class midpoint is the number in the middle of each class. So each class is going to have its own midpoint, and you can do this by actually taking an average, which we haven't talked about. So for now, it's going to be adding the lower class limit to the upper class limit and then dividing it by 2. So it is essentially finding the exact middle of those two numbers as they would be on the number line. Out of all of these, class width is the most important term to be familiar with, and this is the distance between the start of one class and the start of the next. So we're going to talk about all of these terms when we look at our first frequency distribution. So again, the goal is not to have the definition for these memorized, it's just to understand what they mean if you were to ever hear them. One other variation that we are going to talk about in this lecture is a relative frequency distribution. This is going to be really important, especially since percentages are really important to use instead of counts. In the topic 1 lecture, we did go over an example that showed why percentages should be used instead of counts, and we will look at one more of those examples today. So if you notice the bolded statement in the second paragraph, percentages are always better than counts. This is just about always the case. There's very few exceptions that you would want to use counts instead of percentages. But anytime you have different sizes, different sample sizes, you always want to use percentages so that you can compare everything directly. So in our first example, we're going to be looking at test scores from a math class. The classes are already going to be set up for us, so the goal for the first example is just to set up the frequency and relative frequencies. So when I say classes, I'm referring to 41 to 50, 51 to 60, and all the way down. So this example has 6 classes. So we've partitioned this data set into 6 different classes. It's really important to understand that these could be divided in many, many different ways. So they could have 10 classes, they could have smaller class sizes, they could start at 40 and 50 instead of 41 and 51. So you have a lot of flexibility when it comes to setting up a frequency distribution. So I would pause here and complete this example. I will resume with the solution. So one thing that you would notice if you physically scan through this data set is first it would be a lot easier if the data set was ordered from low to high. So sometimes that's something I would do using software if it was on a computer, or I may have ordered it from low to high if the data set was small enough. The other thing that you might have noticed is that it was really difficult to actually find 41 to 50 because you had to look for numbers that started with a 4 and numbers that started with a 5. So as you're setting up your frequency distributions, you may want to keep this in mind. So instead of starting at 41, I may have actually chose to do 40 to 49, 50 to 59, and so on. You would run into a problem down here because this last class would be 90 to 99, and then you would need to create a new class for 100. This is completely fine as long as you don't have a certain number of classes that you need to have. Maybe you want to match two different frequency distributions. But for the most part, you have a lot of flexibility, and since you do, you might as well use convenience to your advantage. So if I were to redo this one, I would start at 40 instead of 41 so that I can just look at the scores that have a 4 in the tens place. So once you are familiar with your classes, the frequencies are how many numbers that you have in between these two values. So when you scan through the data set, the first number that you will find is this 46 right here, and that's the only number that falls from 41 to 50. So that would get, usually people do tick marks. Tick marks are definitely scrap work, so that's not something that you would ever want to do in a submission for either myself or something that you do for a job. So on my scrap paper, I had tally marks somewhere. So there are two numbers in between 51 and 60. There are 6 scores that are between 61 and 70, and so on. So if you didn't complete the entire frequency distribution, I would definitely do this example to make sure that you're able to come up with the same numbers that we did. So on this third column, this is the relative frequency. And here what we want to do is use percentages instead of the counts. This is so we can compare classes of any size at all. So if I wanted to compare this data set to another math class that had 15 students or any amount of students at all that's different, we would need to use percentages instead of the counts. So the way that you get these percentages is you do 1 divided by the total number of values that there are. So add these up and find the total, and then divide each individual frequency by the total. So another thing that I want to do with this example is to use the terminology for frequency distributions to answer the questions of what are the lower class limits, upper class limits, class boundaries, class midpoints, and class width. So I would pause here. There's going to be more than one number for each of these with the exception of class width. So the lower class limits are the lower numbers that appear in the classes. So in this case, it's going to be 41, 51, 61, all the way up to 91. So all 6 of those numbers are the lower class limits. If there was 10 classes, then there would be 10 class limits. The upper class limits are the upper numbers in all of the classes. So that's going to be these 6 numbers that fall in the higher end of each class. So 50, 60, 70, all the way up to 100. The class boundaries are the numbers that is directly in between the end of one class and the beginning of the next class. So the number that's in between 50 and 51 would be 50.5. The number that's in between 60 and 60.1 is 60.5, and all the way up. They do typically include another class boundary for the end of the last class that you have included. So you can really do it either way, but there would be 100.5 for the end class boundary if you ever needed to work with that number. The class midpoints are the numbers that are in between each class. So 41 plus 50 is 91, divided by 2 is 45.5. So the average, or the exact middle, of each of these classes is going to be the class midpoint. Class midpoints are actually used pretty frequently, so this is one I would recommend being familiar with for sure. Finally, the class width. This is kind of what I consider to be the magic number. And the class width, a lot of times people would say is 9, but that's not correct. The class width is actually the start of one to the start of the next class. So the class width here is going to be 10. So 41 to 51 is 10, 51 to 61 is 10, and I say it's the magic number because it's also the amount that each of these above skip by. So I always recommend when you have the choice to pick a class width that is as convenient as possible without really ruining the integrity of your frequency distribution. So try to, keep it as functional as you need it to be while keeping convenience in mind. So this next example is going to seem maybe a little out there, but I really want to emphasize how important percentages really are. So one person conducts a survey and finds that 482 people out of 1,135 prefer dogs to cats. Another person conducts a survey and finds that 421 out of 1,009 prefer dogs to cats. Compare these two survey results. So what I find is that a lot of times the initial thought is to compare those two numbers as they are, 482 to 421. But it is the age-old apples to oranges because they're not out of the same number. So what we would have to do in this case is we need to level the playing field by using a percentage. So a percent is per 100. So what this is doing is instead of finding out how many people out of 1,135 prefer dogs to cats, it is finding out how many out of 100 prefer dogs to cats. So for the percentage on the left, what that means is that 42.5 out of 100 that they surveyed prefer dogs to cats. And for the second fraction, 41.7 people out of 100 preferred dogs to cats. So even though those numbers were originally quite different, when you convert them to a percentage, they are very, very close. So you always want to make sure that you convert whatever you're doing into a percentage when you need to, because it will make it so that you can compare numbers across the board from different sample sizes. So here are the steps to setting up a frequency distribution from scratch. So this would be a case where you just had a big list of numbers given to you, and it's up to you to create the frequency distribution just from a blank piece of paper. So there are 6 steps here. The first one is to determine the number of classes. I would not ever have anything less than 5 classes, and you actually can have a lot of classes depending on what your data set looks like. So I say 5 to 20 here, but depending on what your data set looks like or what your software decides to do, you may end up with having something that has more than 20. The number you select could be affected by convenience. Again, this is important to consider while making sure that you aren't really kind of chunking your data set down too big when you need to be a little bit more specific. So the second step is to calculate the class width. The class width is approximated by taking the maximum and the minimum value and finding their difference and dividing by how many classes you think you want to have. Then what I would do at this point, so for example, if you got 7.82 for your class width, I would round this up to 8. If it's really difficult for you to create, it's probably going to be difficult for someone to read. So I usually pick a number that is, decent for somebody to count by. Next, you choose your minimum value, or you round a little bit down from that to use as your first class limit. And we'll look at this when we see our first example here. Then take your class width and your class starting value to create the rest of your frequency distribution, and then include all of the upper class limits. So I always do the lower class limits and then fill in the upper class limits. And this will all make a lot more sense when we actually view an example. And then finally, take your list of data and put in the number of counts that you have for each of your classes and work on from there. So let's actually look at something specific. The data below is the pulse rates of females in beats per minute, and we want to use this data to make a frequency distribution. This example does give you the lower class limit and the class width. So in this case, we're just concerned about setting up the classes with those lower class limits and class width. So just to emphasize again, when you look at this data set, this big list of numbers, it doesn't really have anything meaningful to you that you can really understand. So you don't really have an understanding of, the way that these female pulse rates look or behave. So that's again why we want to make a frequency distribution and eventually a graph. So the first step here is I would almost always find the minimum and maximum value just to keep this in mind. So the example said to use a minimum value for 60 for the classes, and then use a class width of 10. So in your distribution here, you're going to have lower class limits of 60, 70, 80, 90, 100, 110, and 120. I also included a label here. Sometimes this will say classes, but what you want to do is be specific. You want to say, okay, well, this isn't just the class. It's pulse rates of females in BPM, which is beats per minute. So once you've set this up, your next step is to do the upper class limits. So you want to make sure that your classes not only do not overlap, but also that every single number will have a spot in these classes. So if there was one decimal place up here, you would need to have at least one decimal place down here in your classes. And we'll look at an example that has a decimal places next. Again, the class width of 10 refers to the start of one class to the start of the next. So the 10 has already kind of been taken care of. Now we again need to make sure that this ending number is set up so that every single number in the list has a spot to go. So 69 would be a good number so that we didn't have any gaps here. So for example, if this ended in 68 and we had a 69 up here, that data value would have nowhere to go. So for that reason, this is going to be one less than our class start, and they're going to skip by tens. And again, this is only when there's no decimal values, so that's a new consideration that you would have to take. So once you've done this, then you can figure out your frequencies and then finally figure out your relative frequencies. So I basically, I actually cheated. I used Excel and I put the numbers in order. But what you would need to do is I would go through and I would cross off each number as I found it. So if I'm scanning through the first row, here's a 60. That's in between 60 and 68. 68 is also in between 60 and 69. So I'm keeping track of how many numbers fell in between this span, and then I ended up with 12. So just as we had done in the last example, we would come up with the relative frequencies. And again, to do that, it's going to be the total frequency divided by, so the total frequency for a class divided by the total frequency overall, and then convert that to a percentage. So the last example is going to include a decimal place, and it's just a consideration that you will have to take. So the data below is the commute time to Casper College of fall 2015 statistics students in miles. So this was data that I had actually collected from my students last semester. And this data set does not include those that lived on campus. So when this question was asked of them if they lived on campus, then they said that they lived 0 miles away. So I excluded all of those. So what I would like you to do is to set this up from complete scratch and create a frequency distribution, and then use that to come up with the relative frequencies. One consideration is that you may come up with a different frequency distribution than I do, and that does not mean that you are incorrect. If you have something that does differ from mine, please send it to me in an email and I can check it for you and make sure that everything looks good. So the first thing that I did is I looked at my minimum and maximum values. This is going to make sure that you don't exclude anything in the low or upper end. You may not always start at 0, but sometimes even if you don't have any counts there, you might want to include it. So the minimum value was 0.4, which I rounded down to 0. I wouldn't want to break anything up smaller than a whole number at this point. The maximum value is 27, and so I rounded that up to 30. So I ended up getting, a span that was a multiple of 10, which is really nice. Tens and fives are usually what's most convenient for everybody. So the next thing I did was I picked a class width. So I said, okay, this spans by 30. I don't want to do by tens because that would only be 3 classes. So you want to have enough divisions so that you get a picture for at least 5 classes. So I used the class width of 5. The class width of 6 also would have worked perfectly, but again, I chose 5s because I am comfortable counting by 5s. So I set up my class start by using my width of 5, so the lower class limit skipped by 5s. And so then, if this ended with 4, anything that was in between 4 and 5 wouldn't have a place to go in this distribution. So the easiest way to straighten that out is to just add a 0.9. So we want to make sure that we include everything. If this had 2 decimal places, we would need to have 2 decimal places in our frequency distribution, but we only need as many decimal places as the original data has. More isn't a problem as long as it's correct. So my upper class limits were 4.9, and they did also skip by 5s, but it's not as friendly since they're decimal values. And so then, just like with the previous example, I figured out how many I had. So if your classes are different, your counts may be different, and that's okay. So I had 19 that were in between 0 and 4.9, and then 7 that was in between 5 and 9.9. And as you go up, I had 0 for this class right here. This 0 is very important to include. Sometimes people want to just eliminate this class altogether, but you don't want to do that because this needs to be a continuous number line here. And also, it's important information to say, hey, we kind of have a skip here. So if I were to guess, I have 2 separate kind of populations going on. I would say that these first 2 classes were people that lived in town, and maybe these last 4 were people that lived outside of town or in a different town. And just like before, the relative frequencies are 19 divided by the total, converted to a percent, 7 divided by the total, converted to a percent, and so on. So one thing I would make sure every time is that these percentages added to 100, and then I also always check that the frequencies total to the number that I had in the original data set. We are going to use all of this information in the next topic, so definitely make sure that you are comfortable with this before you move on to the next lecture.